Now let's put it all together. Okay, so your processor is issuing a virtual address, and virtual address being broken up into virtual page number and offset within the page, and that, let's say, used as a tag, and TLB has a full associative cache to store part of the virtual to physical memory map. So if there is a TLB hit, corresponding virtual page number is translated into the physical page number with the page offset, and then that address together, your physical address is basically physical page number and page offset. It's together that many bits, and then that bit pattern will be broken into tag, index, and block offset. Then corresponding index line of the cache will be accessed, tag will be matched, and if it is a it, corresponding block will be accessed, and corresponding data will be accessed using the block offset and return the data back to the processor. Now what happens if there is a TLB miss? Okay, so TLB miss means it first need to go and pick up the corresponding entry from the RAM, from the virtual to physical map, the original one, into the TLB. Okay, at that point it may have a page fault or may not have a page fault. So if it is a page fault, then it will incur a page fault penalty. That corresponding page need to be copied into the main memory first, right? Now if it is not a page fault, that means that data is present in the main memory. So we bring up that corresponding map to the TLB. Then when the TLB is accessed, okay, and corresponding physical address being broken again into the tag, index, and block offset, there can be a miss as well, because that physical memory may not be located into the cache, right? So basically what I'm trying to say here, if a TLB miss also cause a page fault, okay, then it will always cause a cache miss as well, because that memory was not there in the first place in the RAM at all. That means there is no way that corresponding memory will be present in the cache, any hierarchies, right? So a TLB miss, if followed by a page fault, will be followed by the cache miss always. Now if the TLB miss does not followed by a page fault, okay, that means the data is in the RAM, but that does not guarantee that corresponding block is in the cache memory. Okay, so that means it may or may not cause a cache miss. Okay, so observation is this, like if a TLB miss is followed by a page fault, okay, because that entry is pointing to the disk, so it is basically causing a page fault, then that same point, same memory address access on the cache will have a cache miss. Okay, but if it is not a page fault, then we cannot say anything. Like it can be a page fault, can be a cache miss or may not be a cache miss, depending on what other things goes on in the whole system. Okay, so to compute the performance of like hit rate, miss rate, total time to access, etc., that kind of mathematical problem, you have to look towards the given information. Okay, what is the miss rate of the cache, and what is the page fault rate, and usually miss rate also include your page fault rate. So if you think that, okay, page fault rate also causing an additional cache miss rate, usually it is not happen, because when we measure the cache miss, it is independent of the page fault. It is an independent component, it is an independent phenomena. Okay, so page fault rate in the problem and cache rate in the problem are independent quantity, though they have an underlying relation through which we can we will try to I would say wrongly infer some relation between that, because that's true also, that if there is a page fault, that means it will cause next access will to that address will cause a cache miss. But since the miss rate and the physical like page fault rate are measured independently, these two quantity doesn't have a relation. Okay, so we'll possibly do some problem around this in the class, and if you have any question, let me know. I think this is the last page of this lecture, and if you have any question, let me know over email or ask me in the class, or put it on the discussion web or Canvas discussion.